we don't just talk about entropy, although many questions are based on that. Why is the entropy increasing? More moles of gas. But you could also be asked to calculate it. And it's the same kind of thing that we did with the enthalpy. You'll look at how much entropy the products have and subtract how much entropy the reactants have, and then you can see how much final minus initial, how much the entropy is increasing. So, the one difference between entropy and enthalpy is we don't look at a compound and say how much heat it has, because what are we comparing it to? How do you get all the heat out of a compound? We have a base that we set all elements in their standard states at an enthalpy of 0. It's different for entropy. For entropy, we'll actually say, hey, this has this many statistical possible arrangements. Although that didn't really sound like something anybody would say. But we do, and we call that entropy. So you can have an element in its standard state under standard conditions, and it has a certain amount of arrangements it can have. That's its entropy. So you have entropy for elements, but we don't have an enthalpy of elements. We have a change of enthalpy, going from one thing to another. And here's an example. I have 2 moles of hydrogen gas plus 1 mole of oxygen gas turning into 2 moles of liquid. And I have the entropy values, not the change of entropy, but the entropy of the oxygen. And I have the entropy of the hydrogen and entropy of the water. So what I'm going to do is I know that the equation I'm going to use is the change of entropy under standard conditions of this reaction. And I'm assuming these are all under standard conditions. Of the reaction is going to be equal to the sum of the entropies of the products minus the sum of the entropies of the reactants. And this equation comes off the thermodynamics section of the sheet that we get to use on every test. So the entropy of reaction is going to be, we've got 2 moles of water, so 2 times 69.91 joules per mole Kelvin. Those are the units for entropy, moles, joules per mole Kelvin, minus the entropy of the reactant. So I have 2 moles of hydrogen, so 2 times 130.684 joules per mole Kelvin. And I'm also adding to that 1 mole of oxygen, so 205.138. Joules per mole Kelvin. Hopefully you can read that. And let me close my parentheses. All right, so I'll take this and I'll subtract that, and I will get that the change of entropy under standard conditions of this reaction, just math, ends up being a negative 326.686 joules